Here we are going to continue our discussion of the amazing molecule H2O. And in this video segment, we are going to look at 4 properties of water that make it amazing. The first thing we're going to look at in terms of what water does to be so amazing is its cohesive and adhesive properties. So we've talked a little bit about cohesion, and if you will recall, water sticks to itself, and that's this property we call cohesion because of what we call hydrogen bonds, and that's the positive charge that exists on the hydrogen and the negative charge that's on the oxygen. They attract each other, and it's a weak bond called a hydrogen bond. And that is what contributes to the cohesiveness of water. But let's talk about what adhesion means. Adhesion just simply means that water can also stick to other things. Here's a very refreshing example of adhesion in action. If you've ever had a Coke can or a glass or anything that got some condensation on the outside, you've noticed that there were water droplets that stuck to the side. And you may have wondered, why in the world don't those water droplets get pulled down the can by gravity? Well, that's because of adhesion. And this is just the fact that there are slightly positive and negative portions of the materials in that Coke can that are attracted to the slightly positive and slightly negative oxygens and hydrogens and water molecules, and so they stick or adhere to the sides of that container. You've probably also seen, maybe in the early morning, the dew, it kind of hangs on to tree limbs and branches or things, or anytime you've seen water just stick to the ends of your hair and it just kind of seems to dangle and hold there. That's because of this adhesive nature where water actually clings to things. And that's due to the polarity, the positive and negative ends of water. Now, this cohesive and adhesive nature of water also contributes to something we call surface tension. And if you've ever seen one of these little bugs across a swimming pool or a pond or a lake or a puddle, you've noticed that they can miraculously walk on water. And the reason they can do that is because all of these water molecules that exist here at the top of the water are clinging to one another. And so they form a surface tension across the top of the water, and so the insect is actually light enough to walk across that. Now I'm going to leave this molecule of water and its hydrogen bondings up here in the corner because hydrogen bonds are going to constantly play a part in the 4 properties that water contributes and makes it necessary for life. The second property that we're going to look at is water's ability to regulate heat in biological systems. So let's learn a few new vocabulary words here. Water has what we call a very high specific heat. So if we want to talk about what does specific heat mean, specific heat, if you haven't learned this in your chemistry classes, is simply the amount of energy that it takes to raise 1 gram of a substance 1 degree Celsius. So however much energy you have to put into a liquid or a solid or whatever to 1 gram of it to get it to raise in temperature 1 degree Celsius, that's its specific heat. And water has a very high specific heat. So what that means is that it takes lots and lots and lots of energy to heat water. If you want to experience the incredibly high specific heat of water for yourself, all you need to do is boil a pot of water. One thing that you'll notice when you boil water is that the pot itself, which is made out of iron or some type of metal, heats up much, much, much faster than the water. In fact, you'll get to a point where you can touch the iron and it will burn you, and the water won't even seem really that warm yet. And that's because water has a high specific heat. So in terms of biological systems, why is that important? Here's one very specific example of why water's high specific heat is an important thing in biological systems. When you go outside on a hot day and you've been exercising, you tend to get all this stuff all over your skin, sweat. And the whole purpose of sweat is it's supposed to cool you off, but the way sweat cools you off is by evaporation. In order for sweat to evaporate, it has to absorb heat. And so all the water that's in the sweat absorbs lots of heat. And where is it getting that heat? Well, it's getting a lot of it from your body. And so it actually pulls heat out of your body as it evaporates, and that cools you off. So because water, due to all these hydrogen bonding, the reason water has such high specific heat is because when you heat something up, or molecules of anything, when you heat it, tend to move away from each other. But because water has all this hydrogen bonding, it holds itself together because of cohesion, and that means you have to put lots and lots and lots of energy into it to get it to evaporate. So you can pull lots of energy in the form of heat from your body into the sweat in order to evaporate it, and that cools you off. And that's all due to the incredibly high specific heat that water has. Now, there's lots of other examples of why that high specific heat is important, but that's just one example that we can look at. The third important characteristic that water has is that as a liquid, it's very unusual in that when it goes to a freezing state, it actually expands, and that means that it becomes less dense. And that's incredibly unusual for any substance. Most substances, as they get colder, they become more and more and more dense. And water does that down to about 4 degrees Celsius. At 4 degrees Celsius, something amazing starts to happen with water. It actually starts to expand, and that means it becomes less dense when it freezes. Now, why is that important? It's very important because that means that ice does not sink, but ice actually floats. The reason this occurs is, again, because of the hydrogen bonding in water. As water freezes, all of these hydrogen bonds they attach to one another, and water freezes in a very specific shape. And the water molecules actually move away from one another as they freeze, and they line up, so you have all this extra space in between them. And so all that extra space means that overall ice is going to be less dense than water, and so the ice is going to actually float. And that's important because if ice sank, every pond, every stream, even the oceans would eventually completely freeze over because the ice would go to the bottom, and it would cool as it went to the bottom, and it would remain cool, and it would not have access to heat from the sun, and it would be virtually impossible to have liquid water on our planet. The final property of water that makes it so amazing is that it is an incredibly versatile solvent. Now, a solvent is basically a substance that other things dissolve into. So water is able to dissolve most any substance under the right conditions. So here we see a picture of a beaker with salt in it. Now, salt is made up of 2 atoms. It's made up of sodium and chlorine. We call it sodium chloride. And if you'll recall, sodium and chlorine, they bond ionically. So the sodium has an overall positive charge, and the chlorine has an overall negative charge, and that's because there is an electron passed from the sodium to the chlorine. And because they have this positive and negative charge, we call them ions. And we go back to the polarity of water. We have a positive part and a negative part to our water molecules. And that positive and negative portions of the water are going to be attracted to the positive and negative portions of the salt. So if we look at this diagram, here's a salt crystal. And you can see the chlorines have negative charges on them, and the sodiums have positive. And so as they are put into water, the oxygen, which is the negative part of water, is going to be attracted to the sodium, and the hydrogens were going to be attracted to the chlorine. And what you get is an isolation of the ions. So when you see salt actually dissolve in water, what's happening is the sodium is being surrounded by water molecules. As you can see here, those oxygens are attracted to the positive sodium, and the chlorine is being surrounded by water molecules because these positive hydrogens are attracted to the negative chlorine, and then the sodium and chlorine can't get to one another, and so they can't actually form the crystal salt. So because water has this polar nature, it is able to dissolve a plethora of substances in ways that few things can. So let's do a quick recap. There are 4 major properties that make water so special, and most of them have to do with the polarity of water, that it has a positive and negative end, and that contributes to hydrogen bonding. So the first one that we looked at was the cohesive and adhesive properties. The second was the high specific heat that water has, and that allows it to regulate temperature in biological systems. The third that we looked at was that water expands when it freezes, and therefore ice floats. And the fourth and final one is that water is an amazing solvent. Because it has this polar nature of positive and negative end, it is able to dissolve lots of different substances. These are the four main reasons why water is an amazing compound that's necessary to life. And again, all four of them have to do with the shape, the bent structure of water, and they also have to do with the polar nature of water.